Okay, perfect. Okay, everyone. Welcome back to CHADS Network Security and Privacy Cohort, Week 4. Common Network Intrusion Tactics continued. So we'll be picking up where we left off last week with Common Network Intrusion Tactics, and today we'll be learning about packet sniffing attacks, IP spoofing attack types, on-path attacks, replay attacks, and Smurf attacks. Okay, so packet sniffing attacks. A packet sniffing attack is a type of cyber attack where an attacker intercepts and analyzes traffic to steal sensitive information. So packet sniffing is the practice of using software tools to observe data as it moves across a network. Malicious actors may also use packet sniffing to look at data that has not been sent to them. So as we were covering in the last sorry, there's a thunderstorm outside. As we were covering in the last meeting, packet sniffing can be done via Wireshark, most commonly, or TCP dump. TCP dump is more of a command line application, and Wireshark is more of a GUI based application, but can also be used via terminal. Okay, so packet sniffing attacks. So malicious actors may try to insert themselves in the middle of a connection between two devices. Then they use packet sniffing to spy on every data packet as it comes across their device. The goal is to find valuable information in the data packets they can use. Attackers can use software or hardware to look into the data packets. So it is important to notice, okay, so packets consist of a header, body, and footer. Now, a header is usually unencrypted. So the attacker would usually see like the IP addresses, the destination IP, the outgoing IP, and the ports, as well as any headers and any checksums. But the actual contents of the packet are encrypted, and it is incredibly difficult to break that encryption. So it's important to note that the attacker does not know what's in the packet. So if you're sending somebody a cat GIF, they won't be able to recover that it was the cat GIF that you sent out. It would just be a lot of gibberish to them, other than the destination and the origin point. Okay, continue on. Okay, so we have passive packet sniffing here. So it's a type of attack where data packets are read in transit. Since all the traffic on a network is visible to any host in the hub, malicious actors can view all the information going in and out of the device they're targeting. So basically, passive packet sniffing is just seeing what is on the network passively. But active packet sniffing is a type of attack where data packets are manipulated in transit. So you're changing something about the packets. This may include injecting internet protocols to redirect the packets to an unintended port or changing the information the packet contains. Now, then a question comes up is how do we detect this with low computational overhead? So even as I said before, that encryption makes it so the attacker cannot look at anything, cannot infer the actual contents of the packet. What they can do is they can still manipulate it, so they can still change it to whatever they want. Now, this is very easily captured nowadays with low computational overheads by hashing. So basically, when you hash a digest of whatever you're sending. So let's say of like the cat image. If you're hashing it, then it will become a checksum. So it'll be used as a way to detect tampering, but hashes on their own are too unreliable due to collisions. So there's actually kind of improved hashing algorithms specifically for this purpose. So that way, the receiver receives the packet. They're able to check if the hash of the packet corresponds with the encrypted message, and if it does, then it wasn't tampered with in transit. So let us continue going. Okay, so we have prevention methods. So prevention methods are very simple for packet sniffing, but they get into a very difficult category when you actually look at all the metadata that's being leaked. So one way to protect against malicious packet sniffing is to use a VPN to encrypt and protect data as it travels across the network. So when you use a VPN, hackers might try to interfere with your traffic, but they won't be able to decode it and to read it and read your private information. So what this refers to is the header, because all the other information is already encrypted. It's already protected. What a VPN does is it creates an outer layer of security, which is usually, depending on the protocol, is either a TCP or UDP tunnel, is what it's called. But basically, the VPN provider will establish a secure connection with one of our servers, and then they will use a symmetric key transported over that secure channel to encrypt the entire packet, including the headers. So now you don't have access to the IPs, the destination IPs, the source IPs, and so on. So what would happen is the entire packet is encrypted. It is sent via UDP tunnel to a server, to another VPN server that fulfills the request. And then that after that packet arrives at the VPN server, it is decrypted once to see the destination, routed to the destination, and then decrypted a second time at the destination to be used. Some of my work has been looking into VPN protocols and seeing how much metadata they leak and whether you can infer the behavior of an actor just based on the metadata from the packets. And it is actually very successful to just look at the behavior of how many packets are being sent, how big are the packets, what time intervals the packets are sent. That information on itself is very difficult to mask, and it still leaks a significant amount of information. Usually the application you use or the type of application that you're using at that time. So another way to add layer protection against packet sniffing is to make sure that the websites use HTTPS. So very easy. I believe that before this would be signified with the lock icon on Google, but they removed that now because most websites use HTTPS anyways. So the reason you want to use this is because HTTPS uses SSL TLS to encrypt data and prevent eavesdropping. So just a heightened standard for encryption and data transmission. And then avoiding unprotected Wi-Fi. So on unprotected Wi-Fi, you can yourself see that any actor that's connected to a Wi-Fi, as soon as they turn on Wireshark, which is very easy to download, or TCP, that's very easy to import, they're able to infer your, they're able to look at all the packets that are coming in and out on the entire network. So if you're using an unprotected Wi-Fi, you are allowing anybody on that Wi-Fi to sniff your packets and see the destinations and the outgoing ports and run those kinds of inference attacks. Okay, so we have an attack type of IP spoofing. So a network attack performed when an attacker changes the source IP of a data packet to impersonate an authorized system and gain access to a network. So some common IP spoofing attacks are on-path attacks, replay attacks, and smurf attacks. So this will be a little easier to digest as we move on to the actual attacks. So we have the on-path attack. So Attack where the malicious actor places themselves in the middle of an authorized connection, intercepts or alters the data in transit. So basically, on-path attackers gain access to a network, then put themselves between two devices, like a web browser or web server. Then they sniff the packets, they learn the IP and MAC addresses of the devices that are communicating with each other, and then they can pretend to be either of these devices. So again, because the destination and the source are unencrypted in the header, you can easily find that information and you can try to pretend to be one of those actors. However, in modern times, on-path attacks are very difficult to execute because devices are able to, once again, they store a digest of the devices they're communicating with. So a device that is spoofing an IP is usually labeled as suspicious because it doesn't appear on the digest. It is not the same pattern of behavior that the other device was creating. So another type of attack that we have is a replay attack. So in a replay attack, is a malicious actor intercepts a data packet in transit and then delays it or repeats it at another time. So a delayed packet can cause connection issues, obviously between target computers, or a malicious actor may take a network transmission that was sent by an authorized user and repeat it at a later time to impersonate the authorized user. So let's say for the former case, delaying packets is obviously detrimental to your connection, as the data does not reach the intended target, meaning the responses did not reach the intended target. But also, if you're using a protocol like TLS, after a certain period of time specified by the server that you're connecting to, that's using the protocol, if a packet is delayed a sufficient amount of time, then the whole connection is dropped and it has to be reconnected via the handshake once again. So a part of a DOS attack that may occur is the malicious actor would delay all of these packets until the server has to send a handshake, um, a handshake request once again. And what this does is this doubles to triples the network traffic, because now not only are you releasing those delayed packets, further confusing the server and forcing it to reply with an ICMP packet, but also you are forcing both the user and the server to engage in a TLS handshake multiple amounts of times, unless they're using some sort of keep alive protocol. So then we have a Smurf attack. A Smurf attack is a combination of a DDoS attack and an IP spoofing attack. So the attacker sniffs the user's IP address and floods it with packets, which overruns the target computer. It can bring down a server or entire network. So again, you're spoofing IP addresses, and then you are DDoSing the IP addresses that you sniff. What I forgot to mention in the latter slide, in the former slide, is the second portion of my statement where I said that an actor may take a network transmission that was sent by an authorized user and repeat at a later time to impersonate the user. So let's say, especially for systems that do not require passwords, that are passwordless systems that are things like cookies and stuff, those still have to be transmitted over the network. So let's say you gain access to a network system indirectly via like cookies or some sort of MFA. Those packets still have to be sent. So if you capture those specific packets and then replay them at a later time, if there's not enough safeguards that look at the time of the packets, or if you're able to change the data stamp on the packets a sufficient amount of time, to a sufficient amount of hours later, whenever you're performing the attack, by replicating that data flow, you can actually impersonate them and gain access to the network just by taking the packets that they sent that were used to connect the user and then changing the timestamp and replaying it again. However, as I've kind of briefly mentioned, the, a lot of systems will actually have safeguards against this very attack because it's existed for a long time. So usually packets with tampered timestamps will not work in a replay setting. So defensive measures. So using encryption in transit. I mean, this is goes without saying that encryption should always be implemented in your data network transfers. And even now, if you try to set up a server that is unencrypted, it is very difficult to set up a server that is unencrypted in nature. And then also configuring firewalls. So firewalls can be configured to protect against IP spoofing. So that's the question that we have. So IP spoofing makes it seem like the malicious actor is the authorized user by changing the sender's address of the data packet to match the target's network address. So if a firewall receives a data packet from the internet where the sender's IP address is the same as the private network, then the firewall will deny the transmission since all devices with that IP address should already be on the local network. You can make sure that the firewall is configured correctly by creating a rule to reject all incoming traffic that has the same IP address as the local network. So basically just making the assumption that um, all devices with the IP address being spoofed should already be on the local network. Okay, so we have a scenario, and this is the largest scenario, which is why this session is much shorter. However, I can read off the scenario. Just let me find it. Again, all these documents are available, and there are a lot of supplementary documents to help you make sense of things. Let me present something else. Okay, perfect. So in this activity, you will consider a scenario involving a customer of the company that you work for who experienced a security issue when accessing the company's website. You'll identify the likely cause of the service interruption. Then you will explain how the attack occurred and the negative impact it had on the website. So basically what you would be expected to do as a cybersecurity analyst on a case-by-case basis in this example. So you work as a security analyst for a travel agency. The employees of the company regularly access company sales web page to reach for vacation packages or customers might like. You receive an automated alert from your monitoring system, so things like a CM or an intrusion detection system, indicating the problem with the web server. You attempt to visit the company's website, but you receive a connection timeout message in your browser. So you use a packet sniffer. You notice a large number of SYN requests coming from an unfamiliar IP address. The web server appears to be overwhelmed by the volume of incoming traffic and is losing its ability to respond to a abnormally large number of SYN packets. You suspect the server is under an attack by a malicious actor. So you take the server offline, you configure the company's firewall to block IP addresses from sending the abnormal number of SYN requests, but this won't really work because you can spoof other IP addresses to get around the block. So you have to find a more permanent solution. So the instructions, so this is just one way to approach it. This is the most formal way, where you will identify the type of attack, a potential explanation, what the logs show and what this event could be, and then explain how the attack is causing the website to malfunction. For this particular case, because we're dealing with the abnormally large number of SYN requests, I would actually implore you guys to check out the earlier video if you don't know how to approach this issue, because we covered this sort of attack in the previous week. Let me see. Okay. In addition, I've also found a document that I had that helped me with Wireshark. So there's a whole document here that you guys can access that tells you how to read Wireshark in a very like hands-on way, like exactly showing you what the output is and seeing how to read it, and it's segmented off. And then in the very end, it actually has what it would look like when you're using Wireshark. So I would implore you guys to read this and try to use Wireshark on your own if you'd like to learn more about network security, as this is a very large portion of what a network security analyst does. Okay, so let's bring it back to the Google Meet. So that's the scenario. Okay, so perfect. In this session, we learned about packet flooding, packet sniffing, and all the attacks that come along with packet sniffing. We've learned when packet sniffing is appropriate, what to do with packet sniffing, and we also looked at a scenario that you guys can explore in your own time, as well as the how to read Wireshark, a document that you guys can also see on your own time. Once again, my name is Sasha, and if you guys have any more questions, you guys can ask it on Discord. So I'll stop sharing at this time, and then I'll see you guys around.